steep. Yeah, don't go too far. Yeah, have to be a bit careful here, it just gets steeper. Sheer cliff faces down here. Look at that. Okay. So we're going to set up a hydro turbine down the stream there. We just got this old irrigation pipe that was going cheap. That's 3" is it?
75mm.
Yep, 75mm. We've got to go up there, what is it, 50 metres or something up the stream?
Yeah, it's around 50 metres, yep.
Yeah. And as we bring the pipes down in the creek, we can probably just feed them straight down there maybe. We could try one and see if it, you know, bends an end or something.
Yeah.
Let's get started.
Alright.
Is there a tap on that or is it just blocked up?
No, it's actually blocked itself.
Right. Dude, that could be your drain pipe, eh?
Yeah, but unfortunately I can't get in there. Something's crushed out on the end, like a bit of steel pipe like this.
Right.
So I can only get the stick to there.
Oh, okay. So we're going to have to put another pipe in somewhere, are we?
Yeah. So maybe we...
Slightly lower than our intake.
Yeah.
Alright. Can we chip away a wee bit or like just chip a bit out of there?
Well, we could if
Did you bring a hammer?
No.
It'll go viral if we both get washed down the creek.
I just don't want my grinder to get wet. They're expensive to replace.
Yeah, broken bones heal, but tools cost money. Yeah. Oh, are you going to throw it?
What could go wrong? I'll hang on to it.
Oh, don't squash your finger. Yeah.
Yeah, I made it too strong.
This comes that way, really, doesn't it? Yeah, solid, isn't it?
Yeah. Like that?
Yeah, just there would be good because then you can, it's supported there as well.
We've got to go up this high.
Yeah, unless we bent it. You walk out on the pipe and jump and I'll hold it.
Okay. Yep, good.
It's not
Crushed it.
Is it? Not too bad though, is it? Like that's still pretty good.
You know that definitely gives it the...
Yeah, well that's good enough then. Alright, so we're just setting that pipe up. We've drilled holes in it so no gravel gets down into the jets. And we've got that at a level. It's just above that top of that dam. We're draining the water out with this pipe, and we're going to concrete that in. So it's just on a slope heading down, and the water should flow out of that nicely. And we've drained enough out of the dam so that we can concrete that without the water washing the concrete away. Oh well, day one complete. Well done. A few days later, and that concrete set well. Should we wrap it up and make a filter? Just using this windbreak material. We'll wrap that around the pipe, and that'll keep all the leaves out. Like a glove.
Oh yeah, that's good. Yep.
Alright, that's the first join. So we're going from 4" here, and we've got to reduce it down to 3", and we'll take it 3" all the way down from here. Climbed up.
What? How?
Hey?
How?
Climbed up.
There you go. Fucking a monkey. Bloody hell.
Probably a little bit sketchy.
I caught a friend off this bank here that was tying that rope up. Slipped down.
Yeah.
Just before they came all the way down, I just managed to grab her.
You just aimed for that pool, wouldn't you?
We were on this side of the pool.
Oh.
I was hanging on to that that bit of tree there, standing up on the bank. Just as well, she's a small lady.
You wouldn't want a battle coming down. Didn't bring the file, so we're just using a rock to smooth those edges out so it doesn't cut into the pipe. Yeah, I've used this lay flat on some of my joins, well most of them, and it's been there for years and never had trouble.
Oh, that's good. Holds up to the pressure.
Yeah, easy. Yeah, that's looking pretty good so far. Nice straight run with a slight slope downhill. We'll just follow that edge around, and we're having to tie the pipes up with ropes and wire. We're just putting alkathene pipe around the tree, feeding the wire through it so it doesn't cut into the bark. Just getting rid of the loose rocks so they don't fall down the pipe.
Here it goes.
Beautiful. Yep. Yep.
Send it down like that.
They'll just jam, I guarantee it.
Well, I've got all of these 3-inch hose clips off air intakes off the old wrecked cars.
Yeah, nice. Cheaper than buying them new, eh?
Yeah, so they worked out to be $1 each.
Yeah, sweet. Trying to keep the budget as low as we can. It's hard to tell on the camera, but that's like a sheer drop down there, so I'm trying to figure out where to go. It must be a good 30 foot. Jeez, don't fall. That looks like quartz, eh?
Oh God, it is too.
Might be gold in there.
Do you feel like carrying that back up?
Not really.
Oh,
it is pretty heavy too, isn't it?
yeah. Oh, look at that.
The golden flakes in there.
Well, I don't know, but I've never seen it that white before.
Yeah, it's weird, isn't it?
Oh, so it's just a wee seam of it.
Yeah, yeah.
Now do you feel like carrying that bit back?
Yeah. It's still quite weighty as well. Bring the gold pan down.
Yeah.
Yeah.
There we go.
No pockets.
Look at that. All right.
Alright, we're just going to feed this pipe down. Down that edge and cross over between those two rocks down there, just to get around this waterfall. This rubber pipe makes it a lot easier. Okay, I'm going to use the motor out of this old smart drive washing machine which I got at the dump. They have a permanent magnet type motor. The stator is on the inside and that's the rotor that spins around the outside. We'll take that off and I'll show you what they look like. There's heaps of these machines in New Zealand. I'm pretty sure they were exported all over the world, so you should be able to find something similar. Very common over here. This one was free, found it at the dump. So that's what they look like. This one has 42 coils around the outside. Some of them have 36, but it doesn't really matter, you can use either. And there's magnets on the inside of that rotor. So when the magnets pass the coils, it generates the electricity. But the problem is, with the factory wiring, if you spin it, it will put out over 400 volts and very little amps. So I'm going to rewire it so that it decreases the voltage and raises the amps, so it's more safe to work with and more useful for charging a battery bank. You can't really use the output from this as it is because it's such a high voltage and the hertz are fairly high as well, so you just end up blowing appliances up. Right. So I'll hold on to that spline, we might end up using it to mount the Pelton wheel on. So that's what we want, just the tub with the stator attached to the back of it. Everything else can be taken off really. So we'll build the turbine around that, make a bit of a frame under it, and put the pipe in the side, put a Pelton wheel on the other end of the shaft, and the water will generate power. They do have cracks around them, that's quite common, it's nothing to worry about. I've never seen one fly apart yet. Yeah, that's a good frame.
So that's stainless.
Oh yeah. It's not too heavy, is it? Yeah, that'd be about the right size for a base, wouldn't it? Weld some uprights on it and put something that it can sit in.
Little cradle.
Yeah. And we have to be able to weld the pipe to it as well, so you could just put a piece across or whatever and up. Shit, that's just about perfect, isn't it? Perfect. Yeah, that'll do it. Jet comes out where that bottom line is, roughly.
So we're looking around there.
Yep, looks good. Drill it out. Don't break it.
Oh,
now it wants to go like flat, if you can.
like that.
Yeah, yeah. That's it. Now we'll look through and make sure it's in the centre. Oh, it's way off.
What?
Nah, just right. Yep, spot on. So we probably are going to need a longer piece of that, because we want it as close to the cups as possible.
Okay.
That ain't going anywhere. Getting any eggs?
No, I've only got roosters.
Oh.
One of the roosters killed my only laying chicken.
That's counterproductive.
Yeah.
Oh, I think it fell down.
Oh,
Sweet.
perfect.
Knuckles skin extra well in this sort of cold weather, don't they?
Yeah, they do actually.
Nice.
Oh, look at that, and good neck too.
Yeah, that's a good one.
Ah.
Sweet. So probably 100. Crack.
Right about there?
Yep.
Okay. It's pretty overkill.
Bit of an underkill, isn't it? So we're just using scrap metal we've got lying around to make a pivot for the valve, so that we can move it up and down to adjust it. Beautiful. That ain't going anywhere. Perfect.
No, it's the whole frame moving there.
Yeah, no, that's perfectly right.
Lovely.
Good. adjustable valve, complete.
I mean, it's a bit rough.
Yeah, it does what it needs to do there.
You know, and my welding is even rougher.
Blur that bit out.
Yeah.
That's good.
Here we go. Yay!
One
There we
CD.
go.
Perfect.
Ta-da!
Ooh,
Wow.
It's a flash one.
Negative, you hold your finger there.
Oh yeah.
Oh, lovely.
Smooth as, isn't it?
Hold that there.
Got a bit of torque. Perfect.
I'll probably just give up on when it.
Bit of CRC and you might get that drill bit out.
True.
Oh, hang on.
That'll hammer it shut.
Yeah, there we go.
That was getting warm.
Was it?
Yeah.
Oh, it was too. So we'll definitely only have a few seconds.
Yeah. Oh, it's only when it shuts it'll do that, eh?
Yep.
Because it won't take a lot.
Oh, it was like what's the old trick, the frog in the warm water? It's like,
Makes you
is
pee
that
yourself.
getting warm? It's like, nah, it can't be. And I can feel a little bit of a tingle in my hand. I'm like, yeah, no, that's hot.
Never heard that one.
No, I've never heard that saying either,
Like
actually.
the frog in warm water.
Yeah.
You boil it slowly and it doesn't know it's getting boiled
Oh, that's right, yeah.
until it's too late.
It's open.
It's a one of a kind, isn't it?
Definitely.
Work of art. So that'll keep the sun off it. This plastic is quite prone to sun damage, so we're just coating it with paint. That'll protect it for 20 years or so.
Oh, look, what's this?
Alloy, is it?
Yeah.
I think that will do it, because that'll clamp on nice and tight.
Oh, yeah?
Yeah.
Alright, well, let's do that. Oops.
Do the job.
Yep. And then we'll just, if we have to replace, well, I mean, what could go wrong? Do they ever break?
I've only had one ever break.
Okay.
But mine are slightly different, but same sort of plastic, I think.
Yeah. I can't see that breaking in a hurry.
Nah.
I can't see that breaking in a hurry. I can't see that breaking in a hurry. Breaking in a hurry. Breaking in a hurry.
That's pretty bloody good.
Bloody good.
We're just using these splines off the tub of the washing machine, and there'll be one on either side of our Pelton wheel, and then we'll clamp those together.
So it spins and just deflects the water from it.
Yeah, it just keeps it, it's like another layer of protection against the water getting into the seal.
Oh, okay.
I'll do it. Off centre there somewhere. Alright, so this has got to go somewhere, because we're going to get AC out of this. We want to convert it to DC, so this is a 3-phase rectifier. Each phase goes onto these pins, and then that's the positive negative out to the battery. So this has to go somewhere. And that's going to keep it cool too. Like what I did with mine was cut little grooves, and that creates a bit of wind in there, so it keeps this cool because they get quite hot. Just stop that water coming out the back end.
I wonder. Alright. Oh, well there we go.
There's our drain hole. Yep. So that can be propped up. Doesn't have to be even tight really.
Yep. Alright.
As long as it's secure there. Good, that's our drain. Try out this new inverter from Banggood. It's 6,000 watt surge, so it should be a decent amount of power. So we'll just give it a little test up at the house before we take it down. So it's 24 volts, so we'll connect these up in series.
Bang!
Always gets you.
Yep.
Loading up the capacitors. Hold your breath. Yeah.
Hey, it's quiet. I thought it'd have a fan that would.
Only when it heats up. Alright, we'll try that toaster out, eh?
Yep.
Make sure it's not live.
Ready?
Yep. Oh yeah.
Oh, I see. So it loads up, goes when that.
Yep. So it's showing your voltage, battery, so that's obviously drawing quite a bit. Probably 700 or 800 watts, eh? No, that's handling that no problem. Sweet. Oh, no, it works. Very good. Right, we've got this old switch box from Telecom. We're recycling it to put the inverter in. Should be pretty waterproof too, I think, with that seal there.
Yeah, it's looking pretty good.
Goes on there. Perfect. On battery house.
There we go.
Recycling at its finest.
Whoop. Yeah.
That'll do it. Yep, ideal. The wiring can go underneath it and through, eh?
Yep. What else do we need to take down? Nothing.
Just the batteries and the cable inverter, yeah.
Because that's going to be a way away from this, isn't it?
Doesn't have to be. No, it can be right next to it. The closer we get it, the better, because we're poking low voltage through the batteries. Low voltage doesn't like long distance.
Okay.
Yeah, so the closer we get it, the better. Yeah, ideally with like a section open or something with mesh over it. Keep the bugs out.
Yep, I've got some of that mesh there.
Have you?
Yep.
Oh, well, that's probably the best way to do it then. So we've just put this mesh in the bottom to create some airflow for the inverter. Just for when it's running something high load, the fans will start up and it needs to push air through. Don't overdo it.
Oh, I was just thinking that actually.
Do it till it strips and then back it off a fraction. Bing!
Yeah.
Solid as. Ideal. Slave relay for a auto valve. You want to cut these wires? Yep. Some spares as well.
About there?
Yep.
Done.
Seems alright. So this is just like a little mini PLC. If the voltage goes over 29.8 volts on the batteries, it'll shut our valve and shut down the turbine. Because that relay is only small, we're going to put a slave relay on it. When this goes over 29.8, that relay will close, which will close this one, which will send power to our valve. So that's negative. We need positive to go to there. Power the coil on the slave. So that. Alright. So this lab supply is just simulating our battery bank. Bang! Can you remember how to program these? I think that's... Can you see the voltage?
There's, yeah, so 20.6.
Yeah, I think we set, hold set. Alright.
Till it flashes.
Yep. Yeah, so we want U3. That's the program we want. And we set 12.5, so that's way low. Put that up. 29.4, leave it at that. Set, hold set. Bang!
Never gets old.
Never, oh shit, what's that?
These are off. These on.
Okay, so that should be set now. Yep.
Yep,
See that?
that went.
That clicked.
Yep.
Cut. Try again. Alright, you recording?
Right, we're off.
So we're going to test this relay, make sure it's all working. Yep, that's all good. Go back down. Sweet. So that's going to work. So with these wires, we go... This one goes to the drill, this one goes to your positive from the battery, and then we just run the negative from the battery negative to the drill negative.
Okay.
So that when the relay closes, it sends power to the drill.
Well, it didn't explode.
She ain't powered up yet.
Right, power.
Power?
Power.
Alright, so creep it up to 29.8ish. Yeah. So that will drop down
Yep.
when that stops charging. It might sort of skid for a minute, but it doesn't really matter. But it works. Yee-hoo!
And then that automatically stops.
Yep, because what would happen is that would stop charging the batteries. They would go down pretty instantly, below 29.4-ish.
And then that means that drill will stop.
Yeah, yeah.
Awesome.
So that's how we stop it. Ready?
Yeah.
Alright.
Perfect.
So we'll just feed through the power for the sensor relay.
Oh, it's pretty dark. Well, you can just see.
3 wires we'll need here. Yep.
Oh, shit.
Very technological.
Oh, well, if it works, it does.
Been doing it for years.
Don't glue my hand. Like that.
Sweet, yep.
Snap. Joe, it's actually on the verge of snapping, so...
I believe it. It's like 50 years old, that thing.
Yep.
Alright,
It's looking good.
that'll do it. Better go straight down this hill. A couple of 100 metres. Just pulled it apart so it's easier to carry down.
Oh no!
What?
Have to carry this back up.
Why? Oh no! Okay. Wire.
I'm going to do a hose clip, little hose clip, and wire.
Yeah,
Yep.
fair enough.
Yep, nah, we'll keep taking it.
Okay. Oh, hold on.
You have to bleep that one out.
Oh, slippery. Sorry about that, I dropped you. So this is going to be our platform. Let's go clear a little flattish area here somewhere. Okay. That's looking pretty good to me. Water pipe out that way, straight into the creek. Yep. So we've got to bring a few more things down here. Turbine, batteries, inverter, all that. We'll just park that up down here somewhere. And then once all that's set up, we'll run the cable down. Basically it goes straight up there, straight to the house. So it's coming along. And the outlet we will just feed off down straight back into the stream. So it's not actually using any water, it will just be harnessing the energy created by the difference in height between the outlet and the intake. So it's a very sustainable way of generating power. Alright, my mate's gone to open the intake, so we should see a bit of water coming out of here soon. 6mm jet on it at the moment, which we'll start off with that and just work our way up from there. We're going to find out any weak points once we let the pressure build up in the pipe. There's bound to be a joiner or two that will come apart. So that's going in a straight line, probably 10 feet. If it wasn't hitting that branch, it would be going even further. So that's a lot of energy there. Our gauge is heading up to the 50 psi now.
Buddy.
I might not just stand there, because if this one comes off, that's going to get me. Alright, so we're getting out of the way just in case the pipe blows, because 100 psi is pretty decent.
Wouldn't be a pretty fight.
Yeah, there's actually a nice track up here.
Oh yeah, how far up did you get?
You go all the way. It zigzags its way up. So we're around 72 psi. Yeah, it doesn't seem to be going up. Whoa. I was right. Holy crap. It's so lucky we weren't sitting there.
Yeah.
Jesus.
Damn it, I filled my toolbox up.
Oh no.
Was there anything else laying there? Something flew over the side.
Did it? Well, my bag was right there. I'm glad I grabbed it. 72 psi, I think.
And it hadn't even got to the top yet.
Nah, doubt it. Which way are we? That way, is it?
Yep.
There's a rope. Well, you turn around, there's a fucking 10-foot drop there. Yeah, don't pull that too hard though.
Oh,
We'll
yeah.
probably have to come this side, I think. In this corner. That's the turbine ready to go. That noise is just the magnets. A bit of grit on the magnets touching the stator. You should be able to run a microwave off that.
Oh yeah?
With the power coming in from the turbine.
I won't know myself. Mountain man. No more.
High-tech hillbilly.
Yeah. Moving up in the world.
Yep. This will probably put out 60 plus volts, the turbine. So if ever you're working on it, just turn it off before you touch those, because you will get a bit of a zap.
Oh yeah?
The batteries will clamp it down to 24 to 30, so which isn't so dangerous, but yeah, just
Okay.
if it's ever open circuit, just turn it off, because if you touch it, you'll get a decent zing.
Yep.
My old mate, his shirt got caught in the rotor, and it pulled him in and broke his jaw. So
Shit.
but yours isn't so bad with that cover over there. But any loose clothing, just be aware of that when you're working near it.
Yep. Ooh, scary.
Never get used to that.
No.
Just tap that on in case we've got a short out. Just give it a tap. Yeah. No,
Good.
Yeah.
Achoo! Oh, Jesus. Fuck. And time to change undies.
And this one here goes to our voltage sensor, which is up there. So that's reading 25.8 volts. And that's our drill actuator as well. So the inverter should work now. Yep, that's all going. So we're all wired up. Pipes are plumbed up. And he's just gone up to turn on the water, so it should gradually build up soon. Made some improvements down here. We've got some turnbuckles on these end ones, because if they let go, then we don't want our inverter getting wet. And if this one came off, it would throw the turbine down the hill. So this is the most likely part to blow, because further down the pipes come, the higher the pressure. As they go up, it's not so bad. There's less pressure the further we go up. Water will come out that jet. Spin the Pelton Wheel, which spins the magnets over the stator, and that generates 3-phase AC. Goes through the rectifier, which changes it into DC, straight to the batteries, and then from the batteries to the inverter, and that'll go straight up the cable to the house. We'll have obviously breakers in there, breaker from the generator to the batteries, breaker between the batteries and the inverter, and a breaker between the inverter and the cable going up to the house, so that if there's any problems then the breaker will just cut out. We haven't run the cables to the house yet, we're just testing out this side of it. We didn't actually bring down the front cover, so it's going to be splashing out the front just for this test, but we'll bring that down next time. So when the water's spent its energy, it'll go down through the drain hole and straight out that pipe back into the stream. So we're not actually using any water, we're just borrowing some energy from Mother Nature. Here it comes. That's the air coming out of the lines. So the dam is slowly filling up. Oh, here we go.